Hello student, today I will continue the lesson. There's a 11.1 linear motion. Okay, let's see this one topic. Okay, first one we're going to see what means of linear motion. Linear motion is a motion of an object that's in a straight line. Means the object that's moving in a straight line. Okay, let's see the example. Okay, you can see the some of the ladies and also the gentlemen, they are moving across the road, is it? So from one of the gentlemen, they go straight. Okay, the other also go straight lah, but this one they show about the direction. So when they just go straight, this one is an example of the linear motion. Let's see this part. This one is an example for the linear motion of the object. Okay, for the first diagram, they show the rocket. They go straight, go upwards. Then we see the car, they're moving to the right, also one direction, go to right hand side. Then we see the apple, they fall down, they go downwards. Then another one, the last one is a ping pong ball, they hit the pin, go to straight line. So this all is an example for the linear motion. So the object just move in one straight line direction. Okay, from here I'm going to introduce two physical quantities. There's a distance and also displacement. So we need to find out what's the difference for these two physical quantities. Okay, first one we got the direction from the home, after that from the school. Okay, this one is one of the direction to show the north. This part up is the north, down should be the south. Okay, right hand side is the east, then the left hand side should be the west. Okay, so from here we're going to see the first situation. Okay, a student, they start from the house, they go to the east. Okay, go to right hand side. So for 400 meters. Okay, after until the junction here, they want to turn to the right. Okay, turn to the right means they go to the east, they go to the south direction. So from here, they will go downwards. Okay, go downward with 300 meters. So that means now the situation is go to right, and or you say go to east for 400 meters. After that, go to downwards. There's a go to the south for 300 meters. After that, they reach to the school. Okay, if the question asks what is the distance, so your answer is distance means total path length traveled by the object. So that means now this is a total distance, total length that traveled by the student is how many? So it's a 400 plus 300. So there's a total 700 meters. So from here, distance actually they no need mention about the east or south. You no need mention about the direction. So from here they say there's a no direction. So from here 700 meters, that's the answer. Okay, when I ask you about the distance. Okay, now I ask you about displacement. Okay, from a student house, go to school. What's the answer? Is it still 700? The answer sure no. Okay, we see how to find displacement. Okay, displacement, that's a straightforward from the original location, go to the final location. So that means you find a shortcut until you go to the destination. So this one we call displacement. So from here, how to measure the displacement? From this one triangle, we're using the theorem by Hercules. There's a 400, you go to square, plus 300, go to square, then you find the square root. So from here, I get it, there's a 500 meters. So we see what means of displacement. Okay, displacement means the distance of the shortest path that's connected to location in the specified direction. So that means they need to find out what is the shortcut from the original part until to the destination. So from here, displacement equal 500 meters. Then you need to mention about the direction. So now the direction is a southeast. Okay, so there's a here. So this one we call it there's a southeast. Okay, now we go to another situation. Okay, the situation is J. They walk from his house to the bus stop. Okay, this one bus stop. The house is here. The house is at the O. Bus stop is at A. So that means now they move O to A. There's a 1.5 kilometer from his house. Then they turn back. After go bus stop, they turn back. Go to the grocery shop. Okay, for 0.5 kilometer from his house again. So OB is a 0.5 kilometer. After buy some drinks, he walked back to his house. After O to B, then B go back to the O. Okay, so from here we see the question what they want. Okay, what is the J's displacement from his house when he reached to the bus stop? So they ask about displacement. So from here, we just got one direction here, just O to A. So we no need to minus because they never turn back. So from here, we get it. The displacement is 1.5 kilometer. Then you need to mention this one is a east. We follow the direction here. So this one is a east. Okay, second question is when he is at the grocery shop. Okay, for the displacement at the grocery shop, so we find the shortest one. There's a shortcut. So that means we straightforward measure O to B. Okay, we no need to measure from the bus stop, go to B. So O to B is a 0.5 kilometer. Then we need to measure about the direction. So go to left, there's a west. So the answer is 0.5 kilometer to west. Okay, now we continue. After buying some of the drinks, now the J, they walk back his home. So when he reached to the home, what is the total distance traveled by the J? Now the question they ask about total. So that means you need to count when they go to bus stop and go back to the grocery shop, then go back to the home. Is how many? So we need to do the calculation. Okay, total distance traveled. Okay, first one they go to bus stop is 1.5. Okay, after that, from the bus stop, they go back to home, there's a 1.5. Continue, they go to grocery shop. Okay, after grocery shop, they go back to the home. So we need to plus 0.5 and plus 0.5. Finally, they walk 4.0 kilometer. Then you no need measure about the direction because there's a distance. Okay, now the question they ask total displacement. So total displacement, we just count about the shortcut. Okay, the shortcut means straightforward J house, straightforward go to grocery shop, then go back to the grocery shop. So that means we measure right hand side is a positive, left hand side is a negative direction. So from here I show you the calculation. Total displacement when you go to bus stop, go to right hand side, so that's a 1.5. Okay, when you from the bus stop A to O, there will minus 1.5 because you move in opposite direction. After O, you go to grocery store. So that means still left hand side. So you put negative 0.5. After you buy some drink, from the B you want to go to the O. So that's a right hand side. So that means you plus 0.5. Finally, you still at the house, is it? You start from the house and also from the house. So that means your displacement actually is a 0 kilometer. So they don't have any distance or displacement for the J because you finally also go back to your home. So from here we straightforward get it. The answer is a 0 kilometer. Okay, let's see the distance and displacement. Distance is always longer than the displacement because displacement, just now I told you there's a shortcut. So from here, these two measure a length. Okay, I don't care distance or displacement. They also using to measure the length. Okay, after that, the SI unit. SI unit for the distance or displacement, there's a meter. So the symbol is M. Okay, now we're going to see the second physical quantity I want to introduce for you. There's a speed. Okay, speed we define as a rate of change of displacement. So rate means time taken. So during the distance you change, then you need to calculate by the time. Maybe 1 second you can move how many meter or how many cm. That one we call it as a speed. Okay, now average speed is the rate of change of total distance travel. When I say average, so that means you need to plus all the distance, then you need to over total time taken. So from here, the SI unit for the speed, or you can say average speed, there's a ms-1. Okay, let's see how to create the unit. Okay, we see the formula. Speed equal distance over time. Distance, just now I show you, there's a meter. Time we're using second. So if I do the calculation, so after that, the formula is a m over s. Okay, so from here, the unit is a ms-1. Because I bring the s go up, so I put -1. Okay, if I count the average speed, average, when you see this word, you need to take all total. Total distance also over total time taken. So this one we call average. Okay, now we see some example here. A girl, they start from 0 meter, move until 100 meter. So from here they show you the time taken. Move until 10 meter using 2 seconds. Until 50 meter they're using 6 seconds. Until 100 meter they're using 10 seconds. Okay, so from here they ask you the speed of the runner at the point A. So we're using the formula for the speed, distance over the time. So distance over time, distance is 10 meter. Okay, the time taken just 2 seconds. So we do the calculation. So I get 5 ms negative 1. Okay, then we continue speed of the runner at the point B. Okay, point B already is a 50 meter. So they're using the time is 6 seconds to finish 50 meter. So we still apply the same formula. Speed equal 50 over 6. So I get it, the answer is 8.33 ms negative 1. So normally you get the answer is a decimal point. We just get the 2, then enough already. Okay, then we continue until the runner at the point C. Point C is 100 meter. So 100 meter they're using 10 seconds. So we're still using the formula 100 over the 10. So we get 10 ms negative 1. Okay, so this one is how to measure the speed of the runner. Okay, another one. When they're talking about the speed, we no need mention about direction. We no need to say where they go. Just straightforward, you give the answer. They seem like the distance. So this one we call it as a scalar quantities. No direction, just value only. Okay, now I want to introduce is a velocity. Velocity also is the same type as a speed, but this one we need to measure about direction. Okay, the same type as the displacement. Displacement also need direction. So from here, we define as a velocity is a rate of change of displacement. Just now speed is a rate of change of the distance. So distance and speed is a no direction. Now I take displacement, then also velocity, they got direction. So from here I create the formula. Velocity equal displacement over time. Okay, just now the speed is a distance over time. Okay, now the unit still the same, ms negative 1. Okay, we now go and see this one diagram. Okay, the car is moving at the uniform velocity. How I know there's a uniform? You see every time the distance is 20 meter, then every time the time taken different is 1 second. So this one we call it constant velocity. Okay, you see this part. This part, is it still constant velocity? I think no. Can you see the distance further? Okay, the distance keep increasing. Then the time taken still 1 second. So from here, time although is a constant, but the distance changes, then we can say the velocity no more constant. How about the velocity now? The velocity increasing. Okay, when you see the distance further means now the car already is a pickup. They become faster. Okay, so from here, if I want to count the velocity, so there's a 20 over 1 second, so it's a 20 ms negative 1. Okay, if I want to count the velocity here, we need to count first part and the second part because your distance changes. Okay, so from here, initial velocity is 20. Okay, final velocity is 30. So from here, we call it velocity increasing. Okay, keep increasing. You also can say accelerate. Okay, now we're going to see this one diagram. Okay, from the O until go to the C. Okay, every time taken is a 2 seconds. Then the meter keep increasing. So from here, the first question they ask you velocity of the car from the O to A. Just O to A. So we're using velocity formula. Displacement over the time. So displacement is a 4 meter. So straightforward 4 meter over 2. So your answer is a 2 ms negative 1. Remember, velocity got direction. You need to mention the direction. Okay, from here, the direction we see it. You go to the right hand side. So there's a east. Okay, now we continue. Velocity of the car from the A to B. Okay, A to B. So A to B is how long? From 16, then 4 meter. So you need to using the 16 minus 4 meter. Then you divide by the 2 seconds. Okay, so the formula 16 minus 4 over 2. So we get it, there's a 6 ms negative 1. So remember again, they go to the east. Okay, now we go to the last one. The velocity of the car from the point O to the C. Straightforward O to C. So total distance is how many? 32, is it? So 32 minus the 0 over total time taken. 2, so there's a 6 second. So finally I get it, 5.33 ms-1. Then keep mention the direction. Go to the east. Okay, now we see some example here. Okay, for this one situation, we can say uniform speed because every time it's a 10, 10, and also 10. Okay, I cannot say there's a uniform velocity because your direction changes. You go to turn, is it? Okay, let's see this one diagram. This one uniform speed because every time it's a 10. Okay, we also can say uniform velocity because direction just straight line. Okay, we never change any direction. Okay, now we see another one. Okay, the car also turning. When the car just turning, we cannot say same velocity already. Velocity already not constant. Okay, and also you see the speed 10, 20, 30, 40. So that means now your speed also not constant. So from here we can say they're not uniform speed and also not uniform velocity. Okay, how about this one? Okay, although there's a straight line is a constant velocity, but 10, 20, 30, 40, that's a not constant because you keep increasing. So from here we can say uniform speed is no. They're also not uniform velocity. Okay, what situation we call it uniform velocity? When this one is the same, 10, 10, and also 10. Okay, just like the first diagram. So this one is a both also uniform. Okay, now we go to the next one. More increasing. So that means now your car become faster and faster. This one we call acceleration. Acceleration means you are keep go faster. Okay, now you see the acceleration defined as a rate of change of velocity. So that means now the velocity you want to keep changes, go faster. Okay, let's see example, the calculation for acceleration. There's a rate of change of velocity. Means you need to using the changes final velocity minus the initial velocity. Okay, initial means starting. Okay, over total time taken to change the velocity. Okay, we got formula. Okay, acceleration we're using the symbol is a. Okay, small v stand for final velocity. Small u is stand for initial velocity. Then the time taken we still put t. Okay, so the SI unit. Okay, because you take velocity over time. Just now velocity is a ms-1. You over the time again, so they become ms-2. Okay, so here let's see the example. The cyclist cycle the bicycle when starting 0 velocity. Now they keep increasing the velocity, is it? So from here we can say about the cyclist now is a accelerate in 5 seconds. Okay, from 0 velocity until 4 ms-1 velocity. So this one situation we call it as a acceleration. Okay, now we can see the question. Okay, first one they introduce the acceleration formula, change of velocity over time taken. Okay, first one we need to count what is the acceleration for this one situation. Okay, v means final. Final is a 4 ms-1 minus initial. Then over total time is a 5 seconds. So I get it 0.8. So remember the unit ms-2. Okay. Okay, so from here, if the brakes are applied, okay, they go to apply the brake. Now the bicycle will slowly and slow down, is it? And also velocity of the bicycle will decreases. Agree, is it? When until 4, then after that I brake it, and when I just brake, you find it that slow down, velocity will keep decreasing. So this one situation, the bicycle become slow down, is it? So slow down, we call it, the word is a deceleration. Okay, when you pick up, we call acceleration. When you just slow down the speed, we call it as a deceleration. Okay, let's see the first example question. A student, they participate in a 100 meter race. So this one is a distance. Okay, he recorded 12.58 seconds in the event. What is the average speed? So we're using the calculation. Average speed means the total distance over total time. So distance just 100 only. So we just take info. This one is an info. They ask about average speed. So we take 100 over 12.58. So final answer 7.95. Then this one still speed. So ms -1. Okay, then we go number 2. What is the acceleration? Okay, they ask about acceleration of can if you stand from the rest. Sometimes the question never tell you initial velocity how many. They just say rest. So rest you understood there's a 0. Okay, and attains a velocity 10.44. So this one is a final velocity. So the distance is how long? 100 meter. Then the time taken is 9.58. So we mention the info first. So this one all is an info. Okay. Now they want to find is the acceleration. So we apply the formula A equal V minus U over T. Okay. So V is a 10.44 minus the initial 0 over the time taken. So I get the answer is 1.09 ms -2. Because this one is an acceleration. Okay, let's see the example 3. Now the car that travel 800 meters from the point A to the B. Straightforward A until the B 800 meters. They in 65 seconds. Then the car that turn back. Okay, turn back 350 from the point B go to C 30 seconds. So you go to B first, then you turn back, go to C. Means now you are moving in opposite direction. Okay, first question they ask you, what is the speed of the car at the point B? So you just do the calculation, no direction. From A to B, 800. Time taken, 65. So we showed it. This the info first. Distance A to B, 800. Time taken, 65. Okay, when you turn back, B to C, 350. Time taken, 30 seconds. So the first question, 800 over 65. 12.31 ms -1. Okay, B. Determine the total displacement of the car. So displacement of the car, that means you need to count about the negative part. Okay, go to right hand side, positive 800. When you turn back B to C, that means you are moving in opposite direction, 350. So you need to put negative. So from here the calculation, displacement equal 800 minus 350. So your displacement just 450 meter. Okay, what is the velocity of the car? If they ask velocity, means you need to using displacement. So from here your displacement is 450. Then we straightforward 450 over total time taken. So your total time is a 65 plus 30. So that's a 95. So from here I get the answer 4.74 ms -1. So this one is a velocity. Okay, number 4. Shafiq, they run from the point R, okay, to the S, 100 meter up. Okay, go to the north. Okay, after that he turned to 150 meter to the east. Okay, after that from the to the east of the S. So from the S you go to the east, that means you go to the T. Now he continue to running to the U. U is south again, 100 meter. Okay, now the total time taken is a 60 seconds. So first one, I want you to calculate the distance. So distance is no problem, you just plus only. So from here the A, okay, the answer is 100 plus 150 plus 100. So that's a 350 meter. Okay, number 2, average speed. So we take total distance over total time. So we just take 350 over total time taken is 60 seconds. So I get it 5.83. Okay, now we go to C. C is asked about displacement. So displacement, because the Shafiq, they start from R, go S, go to T, go to U. So where is the shortcut? Shortcut is straightforward from the R, go to the U. That one is a displacement. So from here, the C should be 100 meter only. Okay, because you from the R go to U, then you need to mention direction. So if you go to right hand side, the direction is to the east. Okay, last one, there's a D, velocity. So velocity, we just take the displacement here over the time taken. The time taken still 60. So there's a 150 over 60. There's a 2.5 ms negative 1. So this one is a velocity. Okay, after show about the distance, displacement, speed and velocity, now we're going to show one of the instrument. This one instrument can measure all the things just now I told you. Okay, this one we call ticker timer. Okay, ticker timer, the white color, this one we call ticker tape. Okay, the function is to investigate the motion of the moving object. Okay, the object is moving, they want to find out how about your velocity is how many, or they want to find out the acceleration is how many. Okay, let's see the characteristic first. The time taken to make 50 ticks. Okay, they will make the ticks on the ticker tape. Okay, after that 1 second. 50 ticks 1 second. Means 1 second they can give you 50 of the dots. So we can call it as a 50 hertz. Okay, the frequency is a 50 hertz. So remember this word, if I say 10 hertz means 1 second they can make 10 times. That one we call frequency. Okay, example for your fan. 1 second they can turn how many times? If can turn 5 times, that means there's a 5 hertz. Okay, now we're going to see 1 ticks. What means of the 1 ticks? Okay, see the diagram here. This one we call 1 ticks. Okay, dot to dot, the center one, the space, we call 1 tick. 1 tick means a time interval between 2 adjacent dots. Why I highlight the adjacent? Adjacent means the next one. So you need to mention. You cannot say between 2 dots because so many dots here. Maybe the first one and the last one we also can say between the dots. So you must say between the adjacent dots means the next one. First and the second one. So from here, 1 ticks. How to count the time taken? You just take 1 over 50. Okay, then you get the answer is 0.02 second. Means 1 dot to another dot, you just using 0.02 second. Okay, remember this one is a characteristic for the ticker timer. Okay. Okay, now we need to calculate the velocity from the ticker tape. Okay, when you see this one direction means this part should be pulled out first. This one is the initial. This one should be the final. So when you see the dot almost constant distance, so this one we can say uniform velocity. Okay, now we need to do the calculation. Displacement equal length of the ticker tape. Okay, if I say displacement from the ticker tape, that means the length. Okay, now the question they give you, the length is 20 cm. Okay, not whole tab, they give you some of the part only. Okay, time taken. Okay, time taken for this 20 cm is how many? So you need to know inside got how many ticks. Okay, we can do the calculation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just count the space. Okay, the space is represent the ticks. So I find it they got 10 ticks. Remember just now I told you 1 tick the time taken is 0.02. So from here total time taken is how long? 0.2 second. Because you take 10 multiply 0.02. Okay, so from here we can do the calculation for velocity. So velocity equal displacement over time. So now your displacement is a 20 cm. Time taken 0.2. So final, I get it the answer 200. Okay, because you're using cm, then we put cm. cm as -1. Okay, this one is another example. We also can find the velocity, but this one is the tab continuous spaced together inside the graph paper. So from here we got 5 of the ticker tab. Okay, from here we're going to see what is that. Velocity again, length of the ticker tab with 10 ticks. Okay, 1 strip here got 10 ticks. Okay, if not, you go to count lah, you go to measure. Okay, now over the time to make 10 ticks. Okay, from here we're going to see time for 1 tick. Remember just now 0.02 second. Okay, if I go to initial velocity, means the first bar. Okay, first bar. So velocity for the ticker tab number 1. So this one we call initial velocity. If I say final velocity, means you need to find the last bar, the last one. So here is a velocity of the ticker tab number 5. Okay, so now you're going to see the time for 10 ticks. Time for 10 ticks. Okay, one of the strip inside got 10 ticks. So how to find it? We're using the 10 ticks multiply 0.02. So there's a 0.2 second. Okay, now we go to the calculation. Okay, initial velocity is how many? We're going to see the first bar. Okay, there's a 6 cm. Okay, time taken is how long? This one is 10 ticks, is it? So the time taken is 0.2 second. So from here, after you do the calculation, there's a 30 cms -1. Okay, then we're going to see the final. Final is the last bar, 10 cm. So 10 cm also over 0.2 because here got 10 ticks also. So after that, I get it, there's a 50 cms -1. Okay, now I want to introduce another one. There's a special, we call it time interval. Okay, when we're using time interval, when the question asks about acceleration, you need to using time interval. So time interval from the ticker tab, okay, here got 5 bar, is it? So if you want to find the time interval, so you must say 1 to ticker tab, 5. Okay, 1 until 5. So you need to minus. You take 5 minus 1, so become 4, multiply 0.2 second. Okay, so from here I also can show, actually you don't want to minus, I can explain like this. You can say jump. From the first bar, you jump to second bar, so we count 1. You jump to another bar, 2. Okay, 3. Then you jump, 4. Okay, suppose they count like this. Okay, they jump. So if you don't want to jump, you can straightforward to say, total got 5 ticker tab, I just minus 1. Okay, every time you go to minus 1, after that you multiply 0.2. Because one of the strip is 0.2 second. So total time interval is 0.8 second. Okay, so from here I can do the calculation for acceleration. So acceleration equal v minus u over t. What's my v? V is a final, 50. So initial is a 30. So time interval 0.8. So final answer I get 25, sorry, not meter, there's a cm because we follow here. Okay, we follow here, 25 cms -2. So I just write here, okay, that's a cm. Okay, now we go to the following. Okay, this one, the type of the linear motion can be determined from the distance between the dots and also the ticker tab. So from here we see the ticker tab. Okay, we can, from the ticker tab, we can know about the motion of the object. Okay, let's see the first one. Can you see the ticker tab? The dot on the ticker tab is a constant distance. So when it's just constant distance, so we understood the distance between the dot is constant. The meaning is uniform velocity. Okay, how about the second one? Can you see this one? The arrow means they're starting. This one is starting. So when starting closer, after that further. So this one, from the distance, we go to explain. Distance between two consecutive dots keep increasing. Okay, is it keep increasing? Okay, so from here we can say the velocity increase uniformly, or you can say uniform acceleration. Okay, now we're going to see this part. This part is direction again. You see the motion. Okay, we're starting here. This one is a dot. You find the dot starting is a further, then become closer, is it? So from here they say distance between the two consecutive dots decreases uniformly, decreases. So from here we can say the motion is a velocity decreases uniformly. You can say uniform deceleration. Okay, we're using deceleration. Okay, after that we go to see the another one. The direction of the motion again. Okay, can you see the dot? That's a not constant. They keep closer, keep further, keep closer, keep further. So this one we carried. Distance between two consecutive dots is not constant. So we can say there's a non-uniform velocity. Okay. So our lesson just until this part for the ticker tape. So make sure you understand what is the distance, what is the displacement, speed, and also the velocity, and the last one is the acceleration. Then you also need to know the ticker tape, how to measure the motion. Okay, so you need to continue to do the exercise. There's a formative 11.1 from your textbook. There's a page 234. So our lesson just until this part stop 11.1. So the next one should be 11.2. There's a linear motion graph. So thank you for your watching. Bye.